Homework packet 4A, lesson 4.5, problem number 7. Two angles of one triangle measure 28 degrees and 31 degrees. Another triangle has two angles that measures 117 degrees and 31 degrees. Are the triangles scaled copies? How can you tell? So one has 28 degrees, 31 degrees, and you don't know the third one. And the other one you have 31 degrees and 117 degrees, and you don't know the first one. So are these congruent? I mean, not congruent. Are these scaled copies? If these three angles are exactly the same, then they are scaled copies. But how can we tell? Problem number 8. How can you tell whether two squares are scaled copies of each other? Two squares are scaled copy of each other. How can you tell that? Can you actually tell that? All squares? It's kind of silly question. Problem number 9. Draw two quadrilaterals that are not scaled copies, but in which the side of one quadrilateral are twice as long as the corresponding sides of the other quadrilateral. So problem number 9, draw two quadrilaterals, right? So you're going to draw two quadrilaterals that is not scaled, but each side has to be as long as, twice as long. So the first line, let's say AB and A prime, B prime. A prime, B prime has to be twice as long as AB. And then B prime, C prime has to be twice as long as B prime, BC, and so on and so forth, but these two cannot be scaled. Is that even possible? It is possible if you kind of make it slanted, or you can go like that. Right? So draw that. That's just the hint. Problem number 10. Explain why the figures in each pair below are scaled copies of each other, or give a counterexample to show that they need not be scaled copies. So if you have two quadrilaterals, question is, are they always be scaled copies? If not, show counterexample. B, two squares. If you have two squares, are they scaled all the time? If so, explain why. If not, show counterexample. Part C, two quadrilaterals with equal corresponding angle measures. So if you got all the corresponding angles are congruent, then would those two quadrilaterals be the scaled copies? If yes, explain. If not, show counterexample. So for example, part A, let's say two quadrilaterals. They're not scaled. They don't have to be scaled. So that's counterexample. So you say no. Here's my counterexample. Okay? Problem 11. Must any two figures of each type below be scaled copies of each other? Explain why or give a counterexample. So if you have two rectangles, would that always have to be scaled? The answer is no, because here's the counterexample. If I have 1 by 2 rectangle, and let's say I have 1 by 3 rectangles, they're not the same thing, but they're not also scaled because it's not proportional. So how about parallelograms? How about trapezoids? And so on and so forth. That's problem number 11. Problem number 12. Which two figures are not necessarily scaled copies of each other? Two rhombuses, two squares, two circles, two isosceles right triangles. So there are some figures that doesn't have to be scaled copies all the time. So for example, part C, two circles, they always have to be scaled because circle has to be circle. And so does squares. So the question is, how about the rhombus and the right triangles?